Welcome back to UC Davis Live. I'm Satirius Johnson. Proper ventilation is important for a healthy home or workspace. Circulating fresh air from outside can dilute airborne viruses and other indoor pollutants, but when the outside air is thick with smoke, we need to keep it out. What can we do to manage our indoor air and keep it clean and healthy? Joining us to discuss these issues are two UC Davis experts. Richard Corsi is Dean of the UC Davis College of Engineering and an international expert on indoor air quality. He's a UC Davis alumnus, earning his master's and doctoral degrees here, and recently returned to campus to lead the College of Engineering. During the pandemic, he's been involved in national efforts to reduce exposure to airborne viruses, and his concept of a low-cost do-it-yourself air cleaner to combat virus-laden aerosol particles and wildfire smoke has become known worldwide as the Corsi-Rosenthal Box. And Teresa Pistocchini is co-director of engineering at the Western Cooling Efficiency Center and the Energy Efficiency Institute at UC Davis. She leads a team of 11 R&D engineers and a variety of R&D and demonstration projects in building energy efficiency, including HVAC technologies, envelope improvements, and indoor air quality monitoring. Prior to the pandemic, she led a major survey of ventilation in California schools. Welcome to you both.
Thank you.
Thank you.
So before we get started, I just wanted to remind viewers that this is a free webcast. You can watch it live and watch it after the live broadcast on the UC Davis Facebook and YouTube channels and the UC Davis website. We're aware of others posting links saying that you have to pay to watch this video. Please don't click on those links. This is a free webcast, and we are taking your questions live. Leave them in the comment section and we'll work in as many as we can. So Rich, let's start with you, starting with some general principles. How important is indoor air quality, and how do these systems work?
Yeah, so that's a great question. I think the importance is really reflected in human activity patterns. If we just look at where Americans spend their time during their lifetime, the average American prior to the pandemic lived to about 79 years old. It's slightly lower now with the pandemic. But if we look at pre-pandemic activity patterns, about 79 years of life. 69 of those 79 years are spent domiciled inside of buildings, right? And of those 69 years inside of buildings, 54 of those years are spent on average inside of our homes, which really have been understudied from the standpoint of exposure to toxic chemicals. And 26 of those years are spent lying horizontally on a mattress in your bedroom as you're sleeping your lifetime. Only 6 years are spent on average outdoors, and 4 years in motorized vehicles. So we spend a huge fraction of our lives inside of buildings, a greater fraction of time than most whales spend completely submerged below the surface of the ocean. So in many ways, buildings are our ocean as humans, right? And if you look at data for outdoor air pollution levels and indoor air pollution levels for the same chemicals, you can show pretty easily that over our lifetime, the vast majority of air pollutants that we take up into our respiratory systems, we take up while we're inside buildings. And that's true even for pollutants of outdoor origin. So that excites me as an engineer because it tells me that we should be able to design and operate buildings to dramatically reduce population exposures to pollution of outdoor origin. And if we're smart, we can do the same for pollutants of indoor origin.
Right, that's astonishing. I guess, when we think of pollutants, we're thinking of, smokestacks at a factory outside. People don't necessarily think inside their home. There could be, these pollutants of whether it's like your carpet off-gassing or, some other kind of pollutant that can affect your health. And the fact that we spend such a majority of the time indoors, and especially in our homes, that's a huge factor in trying to, mitigate this problem.
Yeah, it is, and there are a lot of factors. So if you and you just mentioned one very important one, and that is source control. There's a famous person in the indoor air quality field back in the 1850s or so, Max von Pettenkofer, and I'm paraphrasing his quote now, but he said something to the effect of, if there's a huge pile of manure in the middle of a room that's causing a stench, the solution is not to increase the ventilation of that room. The solution is to remove the pile of manure. Right. So the kind of first thought that source control is really important. And the first thing we should all be thinking about is how do we reduce sources of pollution that emit directly into buildings, because then we don't have to worry about a lot of the other things that have to be done to try to remove those pollutants once they become airborne, right? So we can design buildings in such a way that we dramatically reduce the amount of outdoor pollution that comes in, but we have to be smart about designing the interiors of buildings so that we reduce the sources of indoor pollutants that sort of mix with the outdoor pollutants when they come into indoor environments.
Right. And I guess when we're talking about, say, the pandemic, trying to reduce the source of the pollutant, so to speak, is trying to get those infection rates down. But there's also the issue of transmission. So what role does ventilation play in transmission of viruses, including COVID-19?
So it's pretty important. That's why, when you're outdoors, you have sort of infinite ventilation, a lot of dispersion, right? So we don't see the kinds of infection rates or transmissions outdoors as we see indoors, where we have much lower airflows, much less dispersion of pollutants. But it's only one of many factors that are important, right? So source control, we talked about. Vaccination reduces the probability that there are sources inside the building. Everybody wearing masks is important, even if you have relatively mediocre masks where the mask is removing 60% of what would come out of an infector's respiratory system, and it removes 60% of what you would inhale. Those two 60% together is an 84% reduction in the inhalation dose. 60% plus 60% of the remaining 40% gives us an 84% reduction in inhaled dose if everybody's wearing a mask, right? It's hard to get 84% reduction by increasing ventilation in most buildings. So masks are a cheap and easy way of dramatically reducing the inhaled dose. If you then superimpose on that improved ventilation, smart ventilation, increased ventilation, right, we can raise that 84% inhalation dose reduction to over 90% pretty easily. So just by adding a couple things together, we get pretty dramatic reductions in our exposure, our inhaled dose to virus-laden aerosol particles.
Right. Just a reminder to people watching, if you're watching us live, we are taking your questions. Just leave them in the comments section and we'll work in as many as we can. Teresa, you've looked at ventilation in school classrooms even before the pandemic. What issues did you find?
Prior to the pandemic, we looked at 104 classrooms that had recently replaced their HVAC systems, all in California in the past prior years. So these were all new HVAC systems installed in existing schools, so essentially swap outs. And the thing that I noticed was that most of the time, the vast majority of the time, new HVAC systems that were installed were capable of providing the California code requirement for ventilation, which in a classroom is 15 CFM per person. So that's a specific volume of air per person, but they generally were not configured and operated to do that. So oftentimes ventilation rates were lower than the target. In fact, over that 104 schools, 80, by our estimates based on carbon dioxide monitoring, 85% of those classrooms were underventilated. And so, we have this perception that, I have a new HVAC system, so everything must be okay. Or one of the things I find very interesting is some say, well, I'm in a new building, it must be well ventilated, for example. Whereas a new building often has like a very tight envelope. And so the risk of a ventilation system failure is even greater. So really what we found is that, you really need, in California, an acceptance test of a ventilation system is required for a new system. So this essentially is a certified test and air balance contractor that goes out and measures the outdoor air in each system and documents it in a test and air balance report. And oftentimes schools historically have not done that, even though it's required, because schools essentially are like self-enforcing agencies. So they need to follow all the rules, but they're the ones responsible for making sure they followed all the rules. And so oftentimes that can be overlooked, generally not on purpose, but it's just not well understood.
Right.
And so this is really, important that a lot of awareness has come into the pandemic, and a lot of this is changing, but it's really important that this testing gets done.
Right. So the rules are in place, but the enforcement isn't happening because it's basically kind of a self-enforcing kind of system.
Exactly.
Right. And so is the issue that the systems don't exist to get schools to where they need to be, or is it just that they are more expensive, or is it just kind of a lack of information that the school systems have when they're buying these systems?
They buy the correct systems. The systems are completely capable of providing the required outdoor air. Like that's almost always true, right? Then what happens is the part where at the very end, the system gets installed, it's heating, it's cooling. And the problem is occupants, there's mixed data on this, but in our study, we showed that we surveyed every teacher in every one of those 104 classrooms. And we asked them questions about their perceptions of their indoor air quality. So, is it smelly? Is it stuffy? Do you feel like you have good indoor air quality? We asked them a bunch of survey questions like this, and we tried to correlate their actual ventilation rate that we measured with the teacher responses. And actually what we found was that there was more dissatisfaction with indoor air quality for rooms that were better ventilated. So the correlation was essentially backwards. And our suspicion, our strong suspicion, is that those classrooms that are well ventilated tend to have more fluctuations in temperature, because oftentimes when you're bringing in outdoor air, it's hot or it's cold, and HVAC systems, the cooling and heating cycles on and off, on and off, on and off. And so you can get drafts. And as humans, we confound feeling comfortable with, we're not great sensors of some of these indoor air quality markers. And so basically what ends up happening, just to come back to the beginning of the story, is school districts are replacing all their HVAC equipment in the summer when schools are closed, right? Go, 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 right? School starting, you got 6 days, you got 5 days, you got 4 days, right? And the technicians are running around. Heating's got to work, cooling's got to work, the fan's got to come on. And then, right, like things kind of get left. And that last step where you have to come back with all of the precision measurement equipment and measure every outdoor air rate and document every outdoor air rate, that's like the last, hour or two of the job, right? It often doesn't get, historically,
right.
Anyway, didn't get done.
Right.
And so as society is becoming more educated about this, like as a parent in my school district, I said, I want to see the test and air balance report, right? I want to see that it was done. And then you can actually, now we have proof, right? We don't have to guess.
Right. And I think before your study, probably most people had no idea that this was even an issue.
Yeah, most school districts are unaware.
Right.
I think obviously growing understanding of this.
Right. And I guess you haven't studied, office buildings and other things like that, but I would assume that maybe this is also an issue there.
So I think, so in California, about 75% of HVAC systems are called package systems. They're essentially boxes that get dropped on a roof or mounted to a wall. And these are not that, there's no, generally speaking, these aren't like at UC Davis, for example, right? We have like an entire facilities department that is running, a very detailed building management system and is running large buildings. They have quite a bit of data. They have skilled technicians, right? And so these types of things don't fall through cracks like they do in, like, for example, a school. You have like one package system per building. You generally know very little about that system, like remotely, right? Like an HVAC technician has to go up, configure each one individually. And so I think some of this does happen in other like light commercial buildings, like small offices, small retail, strip malls, that type of thing. But in many cases, perhaps it's not quite as critical as it might be in a school, right, where you have such a high density of students. I feel like I'd like to see all buildings operating well, but I feel like prioritizing like schools is just such a huge need. Right.
So what effect does poor ventilation have on students, whether they're working and studying?
Sure. I'm not my area of research so much, but collaborated with indoor air quality scientists at LBNL and read some of the literature. But some of the impacts are there's been studies that have demonstrated essentially poor performance on testing, reduced performance on testing and learning. One interesting study that was done looked at various decision-making parameters in response to elevated carbon dioxide concentrations, and found like certain decision-making skills, such as particularly like higher level skills like strategy, were impacted. There is definitely in California, study was done in California by LB now, I want to say 162 classrooms where they tracked attendance and measured ventilation rates in classrooms over like 2 years. And they found a statistically significant correlation between absence rates and ventilation rates. So increased ventilation reduces absence rates, which is huge, right? Like that's a big deal in terms of learning, in terms of the economy, in terms of school district funding. There's also correlation between improved ventilation and reduced respiratory health effects as well that I've seen. So there's quite a number of markers. I think the attendance link being perhaps the most compelling.
Yeah, and if I can add to that, I agree with everything Teresa said. It's and many of us who work in this field are very aware of those studies. I did a big study of indoor air quality in schools in Texas, in Central Texas and the Rio Grande Valley 15, 20 years ago now. But what we found was that when teachers complained about odors, the number one odor they complained about is body odors. About 85% of the teachers said that body odors caused nuisances in their classrooms sometimes or all of the time. And following that up, what we found is that teachers that complained about body odors because of inappropriate, inadequate ventilation were using all sorts of air fresheners in their classrooms. So they were using solid air fresheners, plug-in air fresheners, spray air fresheners. So now they're emitting new pollutants into the indoor environment to try to deal with the odors problems that are caused by the ventilation problems. And a lot of the chemicals in those air fresheners are what are called unsaturated organic compounds. So they are easily chemically reacted with things like ozone in cities that have ozone problems in the late spring, early fall when kids are back in school. And you see interesting chemistry happening in the classroom when you're using these air fresheners that generate all sorts of interesting chemical reaction products, some of which we know are at least irritating, if not worse. So there's kind of this cycle of bad things that happen when classrooms are not properly ventilated. It's a nuisance problem. It causes the problems that Teresa mentioned, but it also causes teachers to take things into their own hands and sometimes do things that are not necessarily the best things for them or their students.
We have a question from James, who's watching on YouTube, who asks, it says, the current standard of ACH is 5 to 6. This standard was pre-pandemic with evidence of Delta increased viral airborne load. Is there consideration to increase ACH standard recommendation? I guess if you can explain what the ACH standard is first, that would be great.
So ACH is air changes per hour in a building. So you can achieve, essentially, you can replace air in your room with air from outside. And then you can also run air through a filter. And so generally speaking, you can also, there's ways to combine the ACH from ventilation and the ACH for filtration, and essentially to try and look at total particle removal. I think this is an area of development and debate, right? So there's not like a for sure answer. We know as we increase ventilation, right, and we increase filtration, we're going to reduce risk of respiratory illness. It's just going to keep getting lower and lower and lower. But at some point we're sitting outside, right? So like, where do we stop? And, the other issue being is that there's we still are, another huge priority is climate change. And so when we bring in and we have to condition, particularly like California overall, most of the time is pretty mild, for example. But if we're talking about, northern, very cold climates, if we're talking about hot and humid climates, like the Southeast, right, there are really significant energy impacts associated with conditioning ventilation air. And so where I kind of stand, my professional opinion at this moment, based on what I know, is that the ventilation rates currently recommended, like in California, the requirement is 15 CFM per person. ASHRAE, the national organization, has a slightly different formula, but it basically lands in about the same place. And I still think that that's an excellent target for buildings. And then to reduce infectious disease, stepping up filtration. So using MERV 13 filters, which have the ability to remove respiratory particles, a significant fraction of respiratory aerosols. And then, in-room filtration, portable air cleaning, Corsi-Rosenthal boxes, those types of devices to add an extra layer, I think is really the way to go. Another tool in the HVAC box of things is called an economizer. And what that does is when a building is calling for cooling and it's cold outside, it brings in extra outdoor air. So that way you can get some extra outdoor air when conditions are favorable and you're actually saving energy. So that's a pretty standard feature on most HVAC systems at this point.
Right. And we haven't addressed like the whole issue of the outdoor air quality, bringing it in yet, which we're going to do in a second. But I wanted to get to this question from Cheryl, who's watching on Facebook. And maybe you've addressed some of that just now, but if you could wave a magic wand and create the perfect system for improving indoor air quality in schools, what would it look like? Would it automatically open, close windows when necessary? Would it have filters or fans? Would it allow user control or be fully automated? And since we don't have that magic wand, what are the achievable things in the next 5 years that would get us close to that perfect system?
I guess I'll start. I'm working on it. The tools we have in hand are pretty close, right? Like the issue is that we haven't been setting up and testing them and operating them correctly, right? This isn't so much of a technological leap we need to make. But one of the issues that we want to talk about today is the fact I mentioned this economizer, right? Outdoor is good, right? Or it used to be. And I need cooling in my building. And so then I economize and I bring in all this outside air. Well, like you said, what if it's polluted? And so having these individual packaged HVAC controls, to having them be able to optimize outside air based on outdoor particulates, and based on temperature in the classroom and temperature outside, and what we know about, potentially even a weather forecast. And it essentially can automatically make all these decisions and hopefully have like some cloud-based controls that could, send information to a facility manager, fault detection features, maybe automatically operate a portable air cleaner. The issue with portable air cleaning tends to be noise. And so, running it at a lower speed when risk is lower, and running it at a higher speed when risk is higher, like if it's smoky outside, are the types of things I think about and I'm working on. The second part of that question, in the meantime, right? I think it's pretty straightforward. Facility managers need to do a test and air balance on every system and make sure their ventilation rate is configured as designed. Teachers should be encouraged to open doors and windows when it's feasible to do so, when it's nice out, when it's not smoky, when it's safe. And then the other thing I really like is monitoring indoor carbon dioxide concentrations, so that when we all are breathing, we exhale CO2, and that essentially serves as a signal to tell us whether or not our ventilation system is working. And so having carbon dioxide monitoring in classrooms can tell us when something has failed.
And that's something that is not happening regularly at this point anywhere, really.
Oh, it's increasing rapidly. Yeah,
okay.
No, it's starting to be adopted for sure.
I would add, I think that one element that Teresa touched upon is our human resources. So I've worked with a lot of school districts in Texas that have crackerjack facilities teams, but too few of them. So they just can't keep up with everything in the entire school district. Can't keep up with all of the different equipment that they have to deal with. And I've also worked with school districts where facility staff are, quite frankly, undertrained. They don't really know what they're doing. And there's usually too few of them as well. So adding to the mix of sort of the balance that we need is both technology, but also training of people that can help school districts that are within the school districts, facilities folks, and increasing the number in a lot of school districts. So there's a human resources factor to all of this as well.
Right. It has to become a priority. I guess a lot of school systems didn't really realize how much goes into it. They figure they hire a contractor, they come in, they put it in, problem solved, but obviously not.
Yeah, and the carbon dioxide thing is really it's been fascinating to watch. As Teresa said, there's been this steep trajectory in the number of people that are buying their own carbon dioxide analyzers and sending their kids to school with them, and schools that are adding them to the classroom, and restaurants that are using them. The thing that's neat about carbon dioxide is it's pretty easy to take that carbon dioxide measurement and convert that into what we call a rebreathe fraction. Rebreathe fraction means if you have a rebreathe fraction, for example, of 3% on a percentage basis, that means that for every time you inhale, you're inhaling 3% of what you inhale, the air you inhale, was gases that came out of the collective respiratory systems of everybody else in the space. Another way of saying that is that if the rebreathe fraction is 3% roughly, every 30th breath that you take is roughly the same as locking lips with somebody who might be an infector. And as they're exhaling, you're inhaling. So we want to keep that rebreathe fraction as small as possible, right? And 3% I've seen in a lot of schools in Texas that are woefully underventilated. We want that number to be down below 1% for sure, as far below 1% as possible.
So, ventilation, bringing outdoor air inside is a major, factor in this. So how can you adjust ventilation when the air outside, the quality is not so great? Maybe there's a wildfire, maybe there are other pollutants outside. How can you adjust for that?
Maybe I'll go first and then Teresa, go ahead.
No, you start.
Okay, so two things. Number one is, of course, we don't want to bring in large amounts of outdoor air when outdoor conditions are horrible during wildfires, for example. If we do, we want to take it in through a design air intake that has good filtration so that it immediately treats the outdoor air, right? But I think this is where portable air cleaners also can play an important role, is that because if they're designed properly and they're appropriately sized for a classroom or an apartment or something like that, they can kind of give you the equivalent of 3 to 4 or more air changes per hour in terms of reductions in aerosol concentrations in the indoor environment. So during wildfire season in Portland, when I was living up there, we sealed up our house the best we could. We were in an old 100-year-old home that had lots of leakage across the building envelope, right? We sealed it up the best we could, and we used a couple of really good portable HEPA air cleaners in our house, and it did the trick. I mean, the indoor environment was much more tolerable than the outdoor environment. And so I think that balance of certain times you really want to actually reduce the extent of outdoor air that you take in, and you can supplement that with a system that can sort of give you the same effect or better effect in many times in terms of reducing aerosol levels in indoor air.
Teresa?
Yeah, so I think one of the things I've spent some time with a couple of different facility managers at schools around the state who have just been very collaborative, trying to really understand their pain points. And one of the biggest issues is, in most cases, like I said, each system is individual and each one has its outdoor air controller inside the box. And so it's not really feasible for a facilities team at a school, to put hands on several thousands of systems, right? Every time essentially they know a fire is coming, right? Or is happening. And so they don't really have, it's just not, this is where we need an improvement in technical feasibility, right? Because this is definitely technically feasible, but it is not currently the situation, right? So because we don't really have the ability to go say, oh, more outdoor air, more less outdoor, it's not like you hit a button on a computer, right, in a school district in most cases. And so that's why this is so difficult. So I think we have to essentially set up outdoor air systems at schools or other commercial buildings to provide essentially the code required amount of ventilation when buildings are occupied. And then that will result in bringing in some smoke during wildfire events. Obviously, in a pandemic, even if we could shut down the outdoor air completely, that would present a significant risk. And which risk is worse on any given day? Trying to make that calculation, I think that's also not very feasible, right? So really, I think the way that we kind of have to operate at this moment, right, is to add extra filtration. Agree with that, right? Because that'll help both with the pandemic and with wildfire smoke, and operate our buildings, in this recommended sort of code required ventilation state. And then if the smoke is so extreme that we can't keep our indoor environment in a school reasonable, right, then that's when you essentially have to send people home, because at home it's much safer to essentially shut off outdoor air sources if you have any, and kind of be within your household. I think that's really, I wish there was some magic solution, but I think that's basically what we have at this point.
So depending upon kind of the need, the air quality need at the time, whether it's a virus or keeping out pollutants or wildfire smoke, school systems and other building managers, they really have to kind of adjust how they're dealing with it. There's no just one magic system solution that will deal with it.
Well, what I'm saying is they really can't, right? They don't have the ability to, as every day is a little different, to go change the amount of outdoor air they're putting into classrooms. That's just not technically feasible right now. And so we just need to set these systems up to provide a code required amount of ventilation, right? And then teachers can open doors and windows to increase ventilation, right, when conditions are good. But I think it's been very hard on school districts essentially to have parents demanding more outdoor air because it's the pandemic, and then demanding less outdoor air because it's smoky. And this is just not, with the current tools they have, they can't manage facilities that way. Right. It's very difficult. And so, and then there's a risk in the rush to open and close outdoor air dampers that something, ends up failing, right? So it's just it's a difficult situation.
You mentioned, sending people home when they can't deal with these situations. So in general, what are some things people can do at home to improve air quality?
I would go straight to source control first, is that we need to educate the public on things that they have in their homes that they should not have in their homes, or if they have them in their homes, they need to increase ventilation or local ventilation in their homes when they use them. Avoid combustion to the extent possible in your house. That means don't burn candles, don't burn incense. If you can avoid natural gas, if you're buying a new home and you have an option, buy one that doesn't have natural gas burners. Avoid certain things that emit a lot of formaldehyde, emit volatile organic compounds. You mentioned carpet. Avoid things in your home that emit endocrine disrupting chemicals. These are chemicals that are associated with plasticizers and a lot of pesticides and flame retardants. There's even low VOC paints now that, for good intentions, a lot of the volatile organic compounds are removed from them, primarily to reduce photochemical smog in air basins like Los Angeles and that kind of thing. But those paints oftentimes are laden with endocrine disrupting chemicals or semi-volatile organic compounds that may not be emitted and cause photochemistry problems, but can cause problems for somebody who's inhabiting a house, especially if they're of childbearing age or have very, very young children. So just sort of becoming educated on sources is important. I think understanding the importance of using your range hood, fan, exhaust when you're cooking is very important. That's different than whole house ventilation. It's local ventilation to basically say, we've got an important source of particulate matter here, oxides of nitrogen, possibly if it's gas burners. We need to make sure we emit them to the outdoor environment and not be exposed to them ourselves at high concentration. And then all the other things we talked about. I think the other thing we haven't mentioned is keeping it dry. So dampness is one of the things we know causes health problems in people that live in damp buildings or work in damp buildings. So doing everything we can to keep our indoor environments as dry as possible.
Is that because mold can grow and that becomes a toxic thing?
What's interesting is there's a ton of research, really great work done at Lawrence Berkeley National Lab on reviewing everything we know about damp buildings. And what we know is that damp buildings make people sick. The actual specific reasons why have not actually been identified. So there's a speculation that must be biological, but it may not necessarily be biological. It may be chemical. There are chemical reactions called hydrolysis reactions that go on that convert chemicals to things that are more toxic than the original chemical. Maybe a mix of those two things, biological agents as well as chemical agents that are formed. But the specific reasons for sicknesses in damp buildings haven't really been identified. We just know that damp buildings make people sick. And that's pretty well, known. Slam dunk on that one. The specific reasons why it's happening are not known. So keep it dry if you can.
Right. Rich, you mentioned source control. So is there some place people can turn to find out what sorts of things can be a problem as far as, creating bad indoor air quality?
So there are some good, the US EPA has a website. If you just Google US EPA indoor air quality, there's a website that has lots of information about everything from air cleaners to sources of indoor air pollution, information about radon in parts of the country, information about formaldehyde and those kinds of things. The California Air Resources Board also has a site. If you just Google CARB indoor air, I think you'll find it. And they have similar types of information. Teresa, I think the California Department of Public Health has a website as well that has information on it. Teresa may know of others.
I think that sounds good to me. Adding on to everything that was said, I think those are all really good suggestions. And these are things I think about because there's only so much under our control. And wildfire events are really not at least under our individual control very much, right? And so all these things that we think about, how can we reduce our air pollution exposure year round so that we're better, so that these very extreme events, right, are less likely to add, we have a less cumulative exposure year round, even considering some of these very extreme events that we experience. In the extreme event, right, and your home, and you're trying to reduce your exposure to the wildfire smoke, obviously sealing as much as you can, assuming you're not creating a lot of indoor pollution. I avoid any significant cooking during a wildfire. Not running exhaust fans, because I've heard people essentially running their exhaust fan to try and make their house less smoky. It does the reverse.
Because it's sucking in air from the outside?
Yeah.
When you take air inside and put it outside, there has to be a conservation of mass. So air goes through all the little cracks in the building envelope and it replaces. One other question I've been asked is, should I run my HVAC? I put a nice good filter in my HVAC system. Should I run my HVAC system fan to help remove smoke? And that can't be answered for all cases because duct systems in HVAC systems leak, and they leak at different rates. And so when you're running your HVAC system fan, you're definitely bringing some outdoor air into your house. The question is, does the filtration win, or does the amount of outside air win? And you don't really know. So I tell people essentially not to do that unless they can essentially test it. Like they have a particle counter, and then you can try running with your HVAC system on, and you can try leaving it off and seeing if it helps or not.
Right.
And then what I do is track, local pollution levels, looking at the EPA station and purple air sensors, and if I see, oftentimes there's like a cyclical pattern, or there's just, the smoke can vary quite a bit. And so when we get some low periods, I try and open up my windows and ventilate my house some, and then close it back down again.
Right.
And I would add that as ducts leak, as Teresa mentioned, it's got essentially the same effect as what you mentioned about local exhaust while you're cooking, right? Teresa, is that and sometimes ducts can leak as much as 20-25% of the air that's going through them. That's a lot of air that's leaking out, and then that air ends up being replaced with outdoor air. Conservation of mass, as Teresa said.
And you mentioned, like you both mentioned, we talk about cooking with natural gas. Is it mostly the combustion of the gas that creates a problem, or is it the frying of oil, or what's the issue?
So it's both. So natural gas emits ultrafine particles, and a lot of ultrafine particles. Also emits what are called oxides of nitrogen, nitric oxide and nitrogen dioxide, emits carbon monoxide, and other things. So it emits lots of pollutants itself. And then the act of cooking, whether it's with natural gas or electric burners, when you heat oils, you can heat them up to a point where those normally liquid oils will evaporate, essentially. And then as soon as they evaporate and get into cooler air away from the frying pan, they condense, and so they form lots of little particles. My experience monitoring indoor air quality in homes is that the kitchen area and even rooms adjacent to the kitchen area can be coated with those particles as they deposit on walls. And then if you add a little bit of oxidants, chemically reactive compounds like ozone to the indoor environment, ozone can react with those walls that are covered with cooking oils and create some interesting byproducts, which again are at a minimum irritating. We don't have a lot of tox data on what they actually do in terms of harm to the body. But yeah, so it's both the cooking, and if you burn your food, especially if you burn meat or burn other things, you're generating what are called polycyclic aromatic hydrocarbons in particles that can actually be pretty toxic. So it's both natural gas basically adds to the pollutants that would normally be emitted from a cooking activity.
Our Lara Moore, who's watching on YouTube, asks, what about natural air cleaning, like living plants indoors? Would this have a significant effect on something like these classroom scenarios?
Well, I can go ahead, Teresa.
Well, okay. So all the carbon dioxide we're emitting, we're breathing, you would need a staggering amount of plant weight to convert that, essentially to mitigate CO2 production. So it doesn't help you from that perspective significantly, but I'm not sure, Dr. Corsi, do they have other benefits?
Yeah, no, there are psychological benefits, I think, of having plants in indoor environments. They have no impact on indoor air quality. So don't be duped by anybody that says, put these kinds of plants in your house. As Teresa said, to actually be able to measure the change in air quality due to uptake to plants in a home or a classroom would require a jungle in the classroom or the home. Literally, maybe 500 to 1,000 plants in the classroom before we actually start seeing a 10% reduction in formaldehyde or VOCs. So that's not a route to go. And if you had that many plants in the classroom, plants emit chemicals called sesquiterpenes and monoterpenes, which again can be very chemically reactive with oxidants in the indoor space. You have to water all of them, so you're using a lot of water. You may be generating biological things when you water all of those plants in an indoor environment, so you create mold problems. So it makes no sense at all with plants. I do think that there are ways that we have not capitalized on for removing pollutants passively in indoor environments. So my team in Texas have been doing a lot of research on clay-based materials, certain clay-based materials, kaolinite in clay, for example, that are really quite good at removing organic acids from the air that can degrade things, degrade works of art. In fact, in Denmark now, they're using clay-based materials in art preservation facilities to try to scavenge organic acids from the air so you don't degrade art. They're also really good at catalytically decomposing things like ozone when it comes into the indoor environment, which oftentimes produces lots of reaction products. Well, when it just decomposes on clay, it doesn't create any reaction products at all. And so we were continuing to look at these benefits of placing clay-based materials in areas that would naturally have good fluid mechanics in a room. So you're not having an energy penalty of trying to drive air past them with fans or that kind of thing. So we place them, behind a set of computers that have fans on them that are already blowing air that direction, or place them near supply diffusers on a ceiling, those kinds of things. So you get this natural contact of pollutants with those materials, and the materials work for you to scrub, if you will, chemicals out of the air.
Now, Rich, you developed a design for a DIY air filtration system. Can you tell us about that project, how it works and how it can be used?
Sure. Yeah, this is really exciting to me. People had started during the pandemic to put single filters on box fans. So other people were already doing that. When I saw that, I thought, that'll work. That'll remove some particle levels from air. The big concern with that is the resistance on the fan is pretty high. So you might have issues with burning the motor out. The motor's got to work harder to try to get air through that layer of filter that causes resistance. So you're going to get a lower airflow. And I thought, how can we make this better? And so one evening I just was up late and I decided I didn't have anything else to do. So I was sketching out on a piece of paper how we might design something that would work better for us. And I said, why don't we actually build what would typically be, a filter box, if you will, like the commercial HEPA filters you purchase off the shelf, have these big metal boxes, right? So what if we built the actual box out of filters? And as Teresa said earlier, a MERV 13 filter should be very effective at removing virus-laden aerosols that are of the size that we know transport the SARS-CoV-2 virus. It's kind of 90% efficient with a single pass through the filter. So if we built the box out of multiple filters, what we really do there, because we're increasing the surface area, we're dramatically reducing the resistance on the fan. So we'll get a much higher flow rate than if we just had a single filter pushed up against the fan. We'll get a much higher flow rate. We'll have these parallel filters will last longer because we're not collecting as much stuff on a single filter. It's kind of distributed across these filters. And it should be relatively inexpensive. And the exercise was really started by how do we help people that can't afford a $300 or $400 off-the-shelf portable HEPA air cleaner? How do we help school districts that can't afford a lot of these? So that's where the idea came from. And it was basically, boy, we could build one of these for $70. It should actually be pretty effective. The only thing I did, so I feel a little bit guilty that my name's associated with, but the only thing that I did is I put that out there on social media. I tweeted it and I said, let's try this. And the next day, a gentleman in Fort Worth, Texas named Jim Rosenthal built one and he tweeted, he said, here's a Corsi box. And then we iterated on what it should actually be called. And so anyway, it ended up being called the Corsi-Rosenthal Box. But it's sort of taken off, like talking about wildfire earlier, it's sort of taking off like wildfire analogy.
Can you describe what it looks like? Can you describe what it looks like?
What's that?
Can you describe what it looks like?
So it looks like, 4 filters that are taped to the seals with duct tape or mastic. They look pretty nice. People are experimenting with these things and making them look like something you'd want to purchase online, right? They can be really nice designs. So it's basically a box fan that's on one side of this box. The box fan is blowing out, so you're sucking air through the filters, which actually helps to make sure the filters are properly sealed as opposed to trying to blow through the filters, right? So a box fan attached to one wall. Most people now are attaching the box fan to the top, so you sort of airflow through the filters, and then the filtered air is moving upwards and creating sort of a recirculating pattern in the classroom or in the home. But they look, people are generating some that look really nice, and I'm just so excited when I see 8th grade students building these in their schools, or gymnasiums that are half filled with these things that are being built. I think Brown University just built 2,000 of them for their university. Their students did. People in Europe are building these. I saw the other day a video with a 4th grader in Hawaii who was so proud of this do-it-yourself filter that she had built. So it's become a bit of citizen engineering. And one of the exciting things to me is Teresa and her team, the team at Illinois Institute of Technology, some other teams have compared these in the laboratory versus some off-the-shelf, pretty good HEPA-based air cleaners, and finding that, boy, these things are just as effective, and in some cases more effective for the particle sizes we care about with transmission of SARS-CoV-2. So that excites me, and it also excites me that we've kind of generated some citizen engineering here and gotten a lot of K through 12 kids excited about learning how to build an air cleaner to protect their families or protect themselves and their classmates. So it's been a wonderful thing. I was interviewed in Portland at one point, and they asked me about how this fit into my sort of general career. And I said, I've done a lot of research during my career. I brought in about $15 million doing indoor air quality research, published a lot of papers, and get pats on the back from colleagues at other universities. But this was one evening of just sketching something out and tossing out on social media. And at this point, late in my career, I can honestly say it may be the most important thing I've ever done in my career, just because of the way this thing has spread.
Well, absolutely. I mean, being able to take research and applying it in a way that is economical and accessible. I mean, all of these parts, the fan, the filters, they could be had at very low cost at your home improvement store or your appliance store, and they can be put together, and it makes a big impact.
It does. And for me, it's generated all sorts of new ideas for how I can develop more low-cost air cleaners to remove volatile organic compounds from indoor air and other pollutants from indoor air. So maybe I'll be bouncing some of those off of Teresa in the coming months.
We took we had some funding from SMUD to do essentially citizen science indoor air quality in schools. That was actually funded right before the pandemic. And then we kind of got stuck because we couldn't go into any schools in the pandemic. And so actually the first thing we did with that was we've been out to 2 schools in Sacramento, a middle school and a high school. And we've done a one-day sort of discussion and lesson on indoor air quality and sensing. And then the second day we build the Corsi-Rosenthal Box filters, and then those go out to the classrooms in the school. And it's really cool because, I mean, yes, we're building the filters for the school, and that's important, but how do we get most students? I mean, many of them don't even think into going into engineering. Those that do think about going into engineering, they don't know. I don't think very many people apply to college thinking, oh yeah, I'm going to be, an HVAC engineer, right? Like that is like not high on the list. Maybe I'm going to build cars, I'm going to build airplanes, satellites, those types of things, bridges, right? And so I think just bringing some visibility to this, and not even, and just thinking about like all these HVAC technicians that we need, and just starting to think about things like fans and filters and airflow, and that's generally not introduced in middle and high schools. So it's been fun, and we have that lesson plan on our website.
Right. I mean, exposing kids to science that can be applied very practically to an aspect of their lives directly. I mean, that's an exciting thing.
Yeah, it's been fun.
Well, this has been a really great conversation. Thanks to you both for coming on today and sharing all your research and work.
Thank you so much.
Thank you. Thanks for having us.
Richard Corsi is Dean of the UC Davis College of Engineering and an international expert on indoor air quality. And Teresa Pistocchini is co-director of engineering at the Western Cooling Efficiency Center and the Energy Efficiency Institute at UC Davis. On the next UC Davis Live, we'll be looking into the effort to save wildlife affected by oil spills, including the pipeline incident off the coast of Newport Beach, California. I'm Satirius Johnson, and this is UC Davis Live.